Alright, today we will be discussing two known bugs about the 3D vFlow methodology, and we'll be examining a model from Shoal Creek in Austin, Texas, and we'll focus on this area near this football field. So if we take a look in RAS Mapper, we can see that the river flows from north to south, and we'd expect the minimum elevation to be at this center line. And at the time of building the model, the only terrain that I was able to find was a 10-meter terrain. And as you can see, it's not that great because the minimum elevation occurs over here on the overbank, but we should have the channel located right here. So when we plot the results on top of this terrain, you can see that the results are only shown here. And the reason that's happening is because if we're looking at that same region here, the terrain essentially acts like the borders of a puddle. And everything here is lost, and everything here is lost. And what we're left with are results over here. So one way to fix the incorrect representation of results is to follow along with Chris's posts about including channel bathymetry into your terrain based off of your cross-sections. So in RAS Mapper, using this interpolated surface, we can create a terrain based off of the profile data. And in the end, what we're left with is something like this, where the actual channel is elevated a little bit less. And when we plot the results, we see that it looks quite a bit more reasonable and in line with the original model results. So that does it for the first bug. We discussed how to create a new terrain from the cross-sections in order to make the results more reasonable. The second bug has to do with unrealistically high 3D vFlow results. So in that same location, we see that at this cell, we're predicting an average depth of flooding of 1.1 feet, and over here, a depth of 1.3 feet. But if we look at the results from this angle, you can see that it seems quite a bit higher, maybe 8, 9, 10 feet higher. And the reason that the results look so high within Google Earth is because the datums between the RAS model and Google Earth differ. So at this location where I clicked, it was 1.1 feet deep and around 482 feet high according to the water surface elevation. So if we subtract those two values, we would expect the underlying terrain to be about 481 or 480 feet high. But the cursor at that location gave an elevation of 472 feet. So the RAS original cross-section and the Google Earth terrain are about 8 or 9 feet off. So that's why the results are so high. One workaround for this common error is to associate the RAS results to Google Earth just by using depth. So here it's in meters, but it's roughly the same, about 1 feet deep, and it's relating the results to the ground and not to mean sea level. So we'll quickly walk through that process of how you would do that. So from the GitHub link, you can download the full zip file, and within that zip file, there's one toolbox with 2 different tools. This is the one that we went through in a previous tutorial, and we'll use the depth tool this go around. So in all ways, it's the exact same as the 3D vFlow water surface elevation, except that the z values are depth values. So as before, you just drag and drop all your different input into here, specify where you want your KMZ saved, and I'll pull up the previous iteration and specified I wanted it saved here. And at first, the results don't show up. And the way you fix that is by going to Properties, Altitude, and then switch this to Relative to Ground. Then it'll show up. So these results are quite a bit more reasonable and in line with the RAS model results. So that does it for the two bugs, two known bugs of 3D Flow. If you have any other comments, concerns, or questions, feel free to reach out. Thank you.